let's talk about the second factor that affects acidity, and that is inductive effects. So inductive effects describe the stabilizing properties that electronegative, write that down, electronegative atoms that are not connected directly to the acidic hydrogen have on the overall acidity. Now, notice what I did to this word not connected, this phrase. I made it bold, I made it underlined, and I made it all caps. So do you think that's kind of important? Yeah, right? It's very important. I need you to realize that this is kind of different from element effects. Element effects had to do with the atoms that are directly attached to the H, okay? Whereas inductive effects have to do with atoms that are not attached to the H. That means they're on other parts of the molecule. They could be 2 carbons away, but they're still going to affect the acidity of the hydrogen, okay? So that's the difference between element and inductive, okay? And the way that works is that whenever a charge can be delocalized over more than one atom, that conjugate base, or that charge, is going to be more stable, okay? So remember what's going on here. Remember that all of these acids, they're always going to give up a lone pair. Give up a proton, and they're going to get a lone pair in return. And they're going to turn negative, and that's called the conjugate base. If I can spread out that negative charge over multiple atoms, that's going to make my molecule more stable, all right? So the way that works is that, by the way, delocalizing, all that means is spreading out. Okay, so when I delocalize a charge, that means instead of it just being in one place, I let it be in 2 or 3 places. I spread it out over an entire molecule.